Welcome back, class, to CSE 143. We are working in Building Java Programs, Chapter 16. That's 16 in binary. And once again, I'm using slides from my dear friend of over 30 years from MIT, Dr. Amelia Gahn. And I have to warn you, she's produced a real barrage of slides here. And I think it's probably a good thing that I'm not going to go through all the slides in detail. I'm focused on my students being able to do the practice hits on the basic and then being able to reverse a linked list. So we're going to go ahead and start here with linked lists. So it's a part of the Java Collections framework. You recall a couple of chapters ago, you learned what a linked list was, and you learned that it's parameterized, but you didn't really learn how it's implemented, and that's what the focus of this chapter is. So the advantages of linked lists are that the nodes are not contiguous, and that means you can insert and delete very easily in the middle of a linked list. An array is contiguous, and you cannot insert or delete without being able to without having to shift everything around. It involves a lot of copying of memory. The advantage of arrays is that you can access them very quickly because since it's contiguous, you can just index into wherever you need to in an array. But sometimes you need a linked list. So the structure that we're going to be dealing with for most of the practice hits is what they call a list node. So a list node just has two things, a piece of data and a next. And here's a simple example of what that list node structure looks like. And it's important to note that a list node, when you declare a variable like a list node here, this is not actually a node. This list here doesn't actually have boxes like this. All that is a pointer. And we don't really pay much attention in Java to what pointers are, but the important part is that it doesn't actually have anything in. There is no data. There is no next pointer yet. It's completely uninitialized. Okay. So Amelia is going to be showing things on these slides here with boxes and arrows. I'm actually going to show you in the debugger exactly what Java does, but we can follow along and do the same kind of thing. So if we create a new list node, what you're going to see is the variable pointing to a box like this. So let's drop into Eclipse and show you that same thing. So I've got Eclipse here, but I've got a special add-in called Visualizer. It's done by Adam Blank, who was a lecturer at the University of Washington and now is at Caltech. Adam created this visualizer so we can actually see the data structures as Java is creating them. So I'm going to try to set a breakpoint here, and you notice I actually can't set the breakpoint there. I'm just going to go ahead and step into the debugger, and what happens is that you can't even look at the code for this line because nothing actually happens. That's how little is happening here. But as soon as we step over this line here, now list gets initialized. And you see it's a list node structure. It has data 0, and it's got a pointer next to null. And the next thing we're going to do is we're going to set the data item to 3. So watch this here. And you see that just changed to be 3. Let's go back to the lecture. So we just demonstrated this here, that we created a list item and we set it to 3. So now we can add a second node to the list by creating new list node, and the constructor just has a 0 value for default, and then we're going to set the lists next to that. So let's take a look at that in Eclipse. So we're going to create that new list node and assign, watch what happens to list node next here. Go ahead and press the key. So the next now points to this new list node with the 0 value there. So let's step back into so we demonstrated that. And it's impossible to work on these linked list problems without drawing some diagrams. It's a very good idea to start drawing them. I'm going to use the visualizer so that you don't have to draw them for the problems I'm doing, but you should definitely do it at home. So next, we're going to show you how to insert a new item in 3 different places: at the beginning, the middle, and the end of the list. We'll take a quick look at how you do that. So to insert at the beginning, first you're going to create a new item. It doesn't have anything to do with the existing item. then what you're going to do is change the next pointer to point to the first part of the list. Then we have to change the list pointer to actually point to us. So at this point, I'm going to jump back to Eclipse. Now, I wrote a clone function, both recursive and iterative. I'm not going to step through them now. I'll do that later, though. It's going to clone this list 1, 2, 3 times. So we now have 3 different copies of the original. And we're going to add an item to the front of this list. I'm going to use a slightly different syntax than shown in the slides because I want to be able to identify where the element goes. So I'm creating it with the value 10. So it just created this temp node with the value 10. Now, in order to put this as the head of, it's actually up here, list front. Maybe I can move this. I can kind of, but it's not going to be pretty. Well, what we're going to do is we're going to put this at the head of that. What we need to do is we need to move this next pointer to point to the list front there. So that's the next thing that's going to happen. See, that arrow just goes up there. And then finally, we need next list front to actually point to this item. So we're going to assign that temp value into list front. And you'll see that list front just sucks that up. So we've inserted it into the front. While we're here, we'll go ahead and take a look at how to do it in the middle. So in the middle, we're going to create a new list item with 11. Now, if I want to start it in the middle here, what I need to do is I need to get this item's next. I need to have that point to here. So the temp's next is going to have to point to the list middle's next. So that's the code there. And you'll see that that line just appears there. And then finally, to hook it up in the middle, I need list middle's next pointer to be pointing down here at temp, just like that. So we suck that in. And then I'm going to set temp to null just so that that line disappears. And then lastly, how do we add it to the end? We're going to create another item that's got 12 in it. And then what I'm going to do is I need to set this one to be over here. So I need take list end, take its next, and then set temp to be that. So that's what we're doing here. So it just sucks that item in, and then finally I'm going to get temp null so that it just disappears. So let's go back and take a look at the slides now. So that was the case of adding to the front. And then the case of adding into the middle, it's the same thing as I showed you. We needed to create the item, then we have the next point to that, and then lastly we have the first item's next point to our new item. And then at the end, same thing as I showed you there. Now, you notice that here we did a next.next. And if you had more items, you don't really want to do next. So there's a very simple way of doing that, which is to have a current pointer, and you can walk down a list. So if your current starts at the head of the list, then you can move the current down to the next item, and so on, and it looks like this. So you can move down a list with current. So there's an example here of how you can walk down there. But I'm going to show you a function that I wrote to clone lists that uses this exact same type of code. And I think that's pretty informative. So let's go back. I'm going to stop this execution and go back to where I'm doing the list clone. So I'm going to run. And I'm going to jump into my first breakpoint. All right, so I'm about to clone this list here. So let's step into this clone code. So I've got the recursive version of the clone code, and just as a preview here, that's the recursive version here, all 4 lines. Here's the iterative version. So I know most of you are thinking, boy, recursion is so hard compared to iterative code, but this is a pretty clear version where recursive code is so much easier. And it makes sense because these lists are by nature kind of recursive. But let's show you how this works recursively. So what we're going to do is we are going to create a new list node. So what we need to do is we're going to duplicate this list. So obviously we need to create a new one of these, and we need to create a new one of these, and we need to get them linked in. So we're going to create a new one of these here. I'm passing in the, let me slide this over a little bit, the data and the next for this pointer. So we created a new variable head. Now you might notice that head appeared down here under clone, and it also sucked this node up here. That's kind of artificial because this thing actually still sits up here. It's just the way the visualizer is showing it. So we created a new node, but this node is really a copy of this, both the data and the next. So the next pointer is kind of shared. They both point to this item here. So now, while the heads next doesn't equal null, we are going to, it really don't stay. We're now going to set the heads next to be this is next clone. So this is the recursive part. We're actually going to clone this part here, and then head.next will point to it. So let's step into clone again, and it's going to create a copy of this item. There's our second item, and now it's going to set the next of this, and sorry, it didn't have to do anything because the head next is null. So we're now going to return this item, and the item that we returned is actually up here. Let's see if I can drag it down here, at least for a moment. And I'm going to move this up here because this guy is really still here. What needs to happen next is that this guy needs to get linked into here. So that's what we're going to do. The head next is going to move from pointing to the old list to this new list item. There it is. Actually worked. So that's how the recursive clone works. Now I'm going to show you going into the iterative routine. So here's the iterative routine. It's fairly similar. We have to create a new node, but the problem is that because we're doing it iteratively, I have to create this new node here just so I have a pointer to reset later. And then I've got to do the same kind of code down here, and I've got to change a bunch of pointers around. So let's go through it. So we're going to create a copy. That's here. This is clone iterative. So I've created a copy of this first item up here. Now I'm going to create a pointer current that points to that head. And that current is going to switch from here to there. I'm going to keep that one back up there for now. So it's going to switch, that pointer is going to switch from here to up there later. All right, so it's going to create a new list node based on this second item. Got a couple of steps. One more step. Okay, so there's the second item. Now what's going to happen is that the current, which is the same as the head right now, the current's next has to point to this new next. Okay. Then we have to move current up to this guy here. So now current is pointing to here. Now it's going to check to see if it's null. If it's not null, then it would go and do the next loop. But since it is null, it's just going to return this. And that creates the clone called list middle. It hasn't been allocated yet. As soon as I step, now it says list middle is that. Okay, we're going to step over the clone just so we get back to the front. So that's an example of how you can use that that current pointer. So while you're moving, oh, sorry, this is the wrong code. It was down in clone. So while you're moving down the list here, you just keep on updating current. And when we were using it recursively, it's even easier because recursion takes care of that for us. Let's go back to the slides. So we're going to skip through this code. This was just another example. You could loop through the list, printing stuff out. So now it gets to the point where it explains that list node can take data. I've already shown you that. And list node can not only take the data, but it also can take the next node. And this is really handy for the practice hits too. If you want to really kind of accelerate things, you can create a list node with the next parameter already built in. So imagine you want to insert an item right in between these two items. We want to add, they want to add it right here. We want to add a node with 5 right there. So you could do this manually and go to the next, and assign and blah, blah, blah. But you could also use this new form. You can create a new list node with 5. And then if current is here, you would go current.next. So the new item will be created like this. It'll have 5 and it'll point to that. If you didn't have current, you'd have to do list.next.next. And then you have to link in this this new item by doing current.next equals that temp. So in practice, it's when you're trying to link something into the middle, you can do that in just 2 steps. You can create a new node and then link it in with another command. So there's a linked int list class. I only use this for the reverse, and really the only difference is that there is a pointer to the front of the linked list. Other than that, it works pretty much the same. There's a bunch of functions you can use with the linked list class. There's of course size. I don't pay too much attention to these. You can add. This shows you how you can add a value. At how you can add a value at a particular place. And again, not super important, and not super important, and not super important, and I'm going to skip past those, really the only important things are down here. So doubly linked lists. This is what I think is very important. A very common interview question is to reverse a linked list. And that's a doubly linked list that has next and previous pointers. And we don't use the dummies. But let's focus on this doubly linked list and how to reverse a linked list. I'm going to try to show you graphically how you reverse a linked list. First, let me talk about the process using this image here. So we've got a linked list that has 1, 2, and 3. I've drawn the pointers outside the boxes just so I can easily erase them and change them. So current is a pointer that will keep track of where we are at each stage. We're going to look at this item 1, and then 2, and then 3. List is the head of the list. We need at the end, we need list to be pointing to this item number 3. And previous is going to keep track of whatever is the previous. So initially the previous will be null. Then after we've processed this item, the previous will be this. Then after we've processed this item, the previous will be this. And finally, when we get to this item, it'll always point back to where we were before. And temp is going to be a pointer that just kind of holds where the next pointer is before we overwrite it. Okay, I've updated the name to be temp next, so it's just a little bit clearer as to what that's for. So let's walk through it step by step. So first we've got current equals the head of the list. Then we're going to step to the previous is going to equal null. And then while the current pointer doesn't equal null, we're going to cycle down this list. So the first thing we're going to do is, our goal is to change this pointer here. But before we change it, we have to save it. So we're going to go ahead and make temp next point to right there. so we don't lose it. Okay, now we're going to update the current. Next, we need to get previous moved up to the current. Previous has been updated here. And then next, we're going to move current up to temp next. See, we saved it here, so it's going to update that. So then we're going to loop around again, and we're going to check this current equal null. Nope. So we're going to continue on. We're going to move temp next up to this next pointer here. Now we need to move the next pointer here to the previous item over there. Now we need to move the previous to the current so that when we get to the next item, it can point back to here. And then lastly, we need to move current up from the second element up to the third. Okay, we got one more loop to go through here. So current isn't null yet, so we're going to save away the temp next pointer. And then, so the current next needs to change from pointing to this null to pointing backwards here to this previous item. Then the previous has to move up to the current. And then we need to move the current up to the temp next, which is now null. And then we're going to come up to the top of the loop again, but now current actually is null. So we're going to drop out of this loop and just have to change the head of the list from over here to point to our previous pointer over here. So what we're left with now is our list points to 3, which then points to 2, which then points to 1, which then points to null. So, we have reversed this list. Now that's a pretty complex procedure. How do you remember how to do that without having to go through this big diagram? Well, there's a couple of things that you should remember when trying to do this. First of all, what is necessary to reverse a linked list? You always need a current pointer. That's a given. That's true of most linked list problems. What's different is that you need a previous pointer as well. And since it's a doubly linked list, that maybe should be a good hint that you're going to need a previous pointer. Remember that the previous pointer always needs to start out as null. And that's because the first thing you're going to do is set the next to be that previous, and it's got to be something. So it better be null because that's where it needs to be after the first round. Then remember, all you're trying to do really is to change the next pointer. Instead of pointing ahead, it's supposed to point behind. Okay, but before you point it ahead, you have to save using a temp variable where it used to point. And then you've already got the where it used to point behind through that previous pointer. So remember, you're going to have to save the temp, then you can blow away the next, then you can update the previous and update the current. So you'll have to play with that order a little bit, but this is the only order that works. If you tried to update current before saving the previous, then you've lost the current. If you tried to do the setting the next before saving it, well, then you've lost that. So the rest of this kind of works itself out. If you just remember, really all you're trying to do is move the next to the previous. You just got to save the right things in order to do that. And combined with just walking down the list through current. So that's the end of chapter 16. I also will be making a bunch of videos for practice it problems, so you should look those up on their own in my YouTube channel. I hope you've appreciated this video. Please like and subscribe.